Okay, so we're looking at the Chapter 4 review notes in question number 1. As this is the data given shows the number of overtime hours worked in 1 week per employee. Use the data to compute the probability distribution and then graph the probability distribution. So what we want to be able to do is we want to find out the probability for each of the hours. And so this is a discrete probability distribution. We have the number of hours going through. And so the probability of any given x, or any hour value, is equal to the frequency divided by the total number of samples. So the first thing we need to do is we need to find n. And n is the sum of all the frequencies, which is this column here. So we add up 8 plus 12 plus 32 plus 59 plus 45 plus 27 plus 18. And what we find when we plug all those into the calculator is we get 201. So each individual probability then would be, so the probability of getting 0 hours is equal to its frequency divided by 201. So 8 divided by 201 gives us a probability. And how many decimal places did they want here? They said to 3 decimal places. So I got 0.040 when I rounded. Then I take 12. The probability of 1 is 12 over 201. And I plug that into the calculator and I got 0.050. And I continue. 32 divided by 201, I get 0.159. 59 divided by 201 is 0.224. And 45 divided by 201, oops, I'm sorry, this one was not 224. It was 294. This was 0.224. Yep. And then 27 divided by 201 is 0.134. And then an 18 divided by 201 is 0.090. And this gives us our probability distribution, which is the first part. I'm checking that 18 because I think I wrote my decimal place wrong. Yep. And again, I'm rounding to 3 decimal places. And so this column here, or this row here, is my probability distribution. The next step then is it asks to graph this. And I'm going to pull down here so I can set up a graph here. I'll set up my y-axis. And I'll set up my x-axis. And I have 7 intervals. I have 0, 1, 2, 3, 4, 5, and 6. And then in this will be a probability axis giving me the probability for each part coming through. And let's see, my highest probability is 0.29, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Put a 10th one here, make that 0.3, and so so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 30 things divided by 10. These should go up by 0.203, 0.06, 0.09, 0.12, 0.15, 0.18, 0.21, 0.24, 0.27. And so there's my probability axis. And so my first one is 0.040, so right in here. Right, and where did I get that number from? Well, I'm pulling these values in and I'm graphing these values for each column. So we'll come back and forth here. So for 1, I have 0.050, which is just a little bit above. Let me say I'll put 4 here, and 5 will be here. And then for 2, I have 0.159, so that's up here. And then for 3, I have 0.294, that's my highest one, it's just about here. For 4, I have 0.224, which is about here. For 5, I have 0.134, which is about here. And for 6, I have 0.090, which is actually right there. And that becomes my probability distribution. And then, so we choose the graph that matches that coming across, and then it asks to describe the graph shape. And it's approximately symmetric. It's not quite uniform, but it is balanced. And now again, your graphs and your probability distributions might be different. There are some different probabilities that it might work its way towards. So you might not have the approximately symmetric or uniform, you might have it being uniform. But in this case, it does tend to balance around 3. It's slightly bigger on the right-hand side than it is on the left-hand side, but not by much. And so that's how you work the first problem in the chapter review.